Okay, I'm going to start building the Tesla coil that I put a video out on several weeks ago. I'm still waiting for parts. I did get some stuff done with some parts that I did get in, but I'm still waiting for a lot of parts that I ordered. So I mentioned before that I bought the schematics from Eastern Voltage Research, and this is just a little flyer that came with the schematics. I can't really show the schematics because they're in the business of selling schematics, and so I don't want to do that. This is just going to be a block diagram, just to kind of go through the operation and the different stuff that I will ultimately need to make or buy. So if we start off with just the input power, and pardon my handwriting, my handwriting has not really improved any since about the third grade, but we're going to start off with input power, and this is 110 or 120. And from here, we're going to go to three blocks here. Right up here we have what they call inrush limiting. Inrush limiting. And this is several components consisting of thermistors, resistors, rectifiers, or a rectifier. I'm sure that's not how you spell it. But you probably can't read my handwriting anyway, so it doesn't matter. And capacitors. Quite a few capacitors, including two of these big guys here. And I mentioned in a previous video that I was able to source some parts from my work. I managed to get a hold of a whole bunch of these, and I'll be using two of them in the build. By being able to get these from outdated equipment that was still functional, this is going to save me $100 right here, give or take. So several various capacitors. And then down here we have, this is much easier, cooling fans. There are two cooling fans that we need. And down here we have a transformer. And that's just taken into, giving us 20 volts AC. And then from the transformer, we're going to go over here to what's called the DRSSTC. That's dual rate solid state Tesla coil controller. And that's going to provide 20 volts AC to the controller. Now, if you're going to build one of these, if you are going to go to their website and buy the schematics, you need to be aware about the controller. Did it even show? Yeah, here's one right here. There's a controller right here. That controller that they sell is about $300, give or take a bit. Now, there are schematics online for a DIY thing. It has the exact same 20 volts input, has the exact same other inputs and outputs, the same LEDs, like everything. I don't know if that schematic was somebody that reverse engineered this one and just put it out there, or maybe the person who developed this one did that one previously before they started this. I don't know where that schematic came from. You can also buy a really cheapo one on eBay coming from China for like $30. And just looking at it, it looks just like the schematics that you can get online. And I looked into building one. I actually downloaded the schematics to build my own. But price of components, it had cost me 20 or $25 to build it, and I can buy it for 30. The only downside to buying it, the $30 one, is that Eastern guarantees that this will work in that Tesla coil. If you buy a $30 one and a Tesla coil doesn't work, now you're left wondering, is it the cheapo controller or is it something else in the system here? Whereas if you buy their $300 one, you know that that is going to work. And if it doesn't work, then it's something else and not the controller, more than likely. Plus, you'll have their full support if you go their route. But I'm going to cross that bridge when I get to it later. I was fully planning on just building my own, but when I looked at the cost-wise, you know, 25 bucks or 30 bucks to build it versus buy it, I don't know. And I might try to sell a bunch of these extra ones, capacitors, and I have a whole bunch of these IGBTs extra as well that I could sell. If I could sell enough components, if I could sell enough stuff to raise the money to buy Easterns, then I'll go that route. If not, I might just buy the $30 one just to try it. But like I said, that's going to come up much later in the build. Now, the controller needs to get signals from something. So there's a handheld MIDI controller. So this right here, this controls this, and then this controls this. And this, they actually give you the schematics for just a very simple interrupter. It's not a MIDI, it's just an interrupter, which will just make it buzz, but it won't make it play music. You can buy MIDI controllers on eBay as well, or you can buy theirs. I forget how much theirs is. Maybe 100 bucks, give or take. I really don't remember. Don't quote me on that. But I do know that's around 300 or 350. So anyways, like I said, you've got that controller, but you need the interrupter, or the MIDI. And there's combinations, interrupter MIDIs. And again, that just takes music files, and that sends that information via a fiber optic line to the controller. So this is fiber optics here going to the controller. And then from here, the controller goes to a transformer, and then that goes to a gate drive board. Gate drive board. And then the gate drive board controls the IGBT, or they call a half bridge assembly. Half bridge assembly. I got a comment on my previous video saying that I needed 4 of these to put it up in a H-bridge configuration. Well, that's true if you're building a different Tesla coil. You can get a big one or a medium-sized one. They also sell kits for smaller ones, like these little small ones here. So I really don't have the room for the big one. Plus, I got a lot of neighbors, and the big one makes bigger, more noises. So I decided to go with a medium-sized one. Plus, the really big one that uses 4 of these would be like twice the cost. Like almost literally twice the cost. So for the one I'm building, it's only a half bridge, so I only need the 2. Now the IGBT that they call for in these plans uses one IGBT, well, 1 brick, but there's 2 inside. It's like a dual unit. I already have these, but to turn that into a dual unit, what I'm going to do, all I have to do is take this copper bar. It's got this weird plastic coating on it, because I salvaged this out of something else. This was a much larger bus bar, but that will go there. That's connecting the E to the C like that, and that now gives me the dual single brick that calls for in the schematics. Obviously I need to clean that up a bit. I need to drill a hole here, but that will get bolted on just like that, and then that part will be done. Okay, so the inrush limiting goes to the IGBT. I'll just put IGBT. IGBT. That's not an L, that's an I. And these big capacitors are, you know, they're going across the lugs here. I think I got to look at the schematic better. But coming off of this bar here, coming off of this, is going to be the main out. That will go through a capacitor bank. I'll just put capacitor bank. That is going to be a circuit board that holds 8 of these guys right here. And you can see the value. Can you? Yeah. 2000 volt. So 8 of these on a printed circuit board. And then from there, we go out to the primary coil. Primary coil. Now there are two current sensors, transformers, here that send information back to the controller. And then of course you would have the secondary coil with the big donut on the top. So this would be the secondary coil. And that is pretty much it. Again, you're not going to be able to build one from this. This is just kind of a block diagram. One of those cooling fans goes to that capacitor bank there. The other one is probably, well, for the heat sink here. These guys are on a rather large heat sink. And a lot of this equipment here will be mounted right on this assembly. This half bridge assembly, that's this huge heat sink with those two. Again, there'll be a couple of those big capacitors mounted right here. The rectifier will be mounted on here somewhere. A couple of resistors and other capacitors will be mounted right on there. So this is kind of, a lot of this equipment is kind of same as this equipment here. So again, I have this. I have the parts ready to make this. I just made that. I'll show you here in a second. Not quite able to make the transformers yet. That I'll talk about later. That I think I have one. Those are easy. That's easy. So I got a pretty good start. So I decided, as I said, to start with the gate drive board. And when you look at the schematics and you just build one from the schematics, you might make something like that. Now some of you might be looking at this and saying, that's not going to work. And if you're that person saying that's not going to work, well, I've got something to say to you. You are 100% correct. This is not going to work. But see, when I made it, I didn't know that. Now, this transformer here, like I said, that will be... I got the wire. I got the transformer wire to wind it. And I've got one of those donuts, but that's not really the right one. I salvaged this off of another piece of equipment. It's got some glue and crap on it. I could use this in a pinch if I had to. But I need the same ones for these two over here. So I ordered like 10 of these on eBay. They're coming from China, so I probably won't get them till August. So I could wrap that and use it, but I'll wait until I get the ones in the mail. But the idea was to just mount that transformer right there. So what I did was I took a picture of this and I sent it to Eastern Voltage Research, to their tech support people, to ask them if it was okay to mount that on the board, because on the schematics it's a separate thing, and they actually sell this as a separate thing. It's like 20 bucks. So I could just buy it already wrapped, but I want to do as much of the work as I can. You know, I could just buy all of these and just put it together, but I want to actually build as much as I can. I want to do more building and less buying, if that makes any sense. So I use the phrase a lot sometimes, you don't know what you don't know. And to me, looking at it, I'm like, yeah, sure, that would work to just mount it on there. But I'm thinking, well, I don't know what I don't know. There might be something to it. There might be some issue that would prevent you from doing that. So I took a picture of this and sent it to them and said, would it be okay to mount it there? They replied back, very nice. They didn't even answer that question. But he very politely told me that this will not work. Because when I built this, I knew nothing about ground planes and return loops and all that nasty kind of stuff that happens with high-frequency electronics. So they sent me a photo of what it should look like, and he explained how the return path, all of the ground returns should be on the bottom of the board with no open loops, and the traces on top. And also these connectors are not good either. Now they do sell this board ready to go, but it's designed to go on their IGBT. Obviously, that won't work with my setup. So I took their advice and I redesigned this board, and this is what I now have. And this will then bolt right there, just like that. So I've got all the components and the traces on top. You know, I'm almost ashamed to turn this over. Okay, so here's the thing. I've been printing my own circuit boards for several years. But this is the very first time I've ever decided to try the green, the green mask or whatever it's called. I never knew how to do that, and I just recently found some videos on eBay. I just recently found some videos on YouTube showing how to apply that UV curable green mask. And I'm like, oh, that'd be awesome if I could put that on my circuit boards, because I'd never done that before. So I watched a ton of videos on how to do that. And basically, here, let me show you what the stuff looks like. And I didn't record any of this because I didn't know what I was doing. I was experimenting. I've never used this before, so I could have been doing it completely wrong. And there's plenty of videos on YouTube telling how to do it. This is the stuff right here. I got it on eBay. I actually got 2 tubes of this for like, I don't know, 10 bucks for 2 tubes. And this goes a long way. But basically, you just squirt it on, and you take a piece of plastic with a mask. This is what I used here. That's just hand-painted black. I just used model paint. And those masks would go on the solder pads where I wanted to solder. So you just squirt a bunch of that on there. You put your plastic on and you squeegee it out, and then you put it in a UV box. And I just basically made a UV box with a couple of UV flashlights and left it in there for about 15 minutes, and that seemed to work. And then you take that off, and of course what the UV light didn't get, you just wipe off with alcohol, and you're ready to go. Now, like I said, all of those videos I watched, they squirted the stuff on, they put it on, and they squeegeed it out. Well, I tried that on the other side, and I got very bad results. Usable, but ugly. So that's what that side looks like. And I even noticed when they were doing it on YouTube, like, okay, so you would watch a 15-minute video, and 12 minutes would be them squeegeeing it all out and trying to get it nice and even. And then they take it out and it's all uneven. You can see that's thicker, that's thinner. I don't even know what happened there. Just very, very unevenness of the stuff. And it made a mess. It squeezed out around the edges. It just made a huge mess. Got all wrinkled and messed up. Again, this is usable. It just doesn't look good. So what I did for this side was I experimented a little bit. I put some of the stuff in here and I put some alcohol in here and I thinned it down because you can clean it up with alcohol. So I thinned it down with alcohol and I just brushed it on a scrap piece of circuit board and tried that, and that worked. So then what I did was I airbrushed it. I mixed up some, I thinned it with alcohol, put it in my airbrush, and I just airbrushed it on there. And then I put the mask on it. And then put it in my UV box for 15 minutes. And this is almost not embarrassing. I mean, this is all, I'm about 90% happy with this and maybe 55% happy with that. If I was building this for a customer, this would not go. I would have cleaned that all off and started over. But just for me, experimenting, playing around, besides, this stuff doesn't even have any effect on the operation of the stuff. This is just, I'm just experimenting, I'm learning how to use stuff. But by thinning it down with alcohol and airbrushing it on there, I think if I practice that method a few more times, I'll get it even better. Some reason it didn't stick very well here, not sure why. And a little spot there, again, I'm not sure why. A little blemish here and there. But I think that's the way to go. So this is almost ready to go. The transformer will go right about there. And coming off the transformer, it's a triple wound transformer. So there's one input, then you have an output coming over here, driving this one, and an output over here, driving this one. And I will figure out some kind of a mount to put that there, either flat or vertical, maybe vertical. I'll 3D print some kind of a little mount thing to make that vertical. I don't know. But, so the input will come in and wrap around it. And then you have an output, you'll have a positive and a negative here, and then same thing, positive and negative there. So I still need to do that. So this whole square here and this whole square here are the ground return planes. That pad will rest on that pad here. Same with that pad will rest on that pad there. And then that should work. That more resembles the photo he sent me of the board that they make for their unit. And so that one's pretty much ready to go. And plus I put the pretty side up. I experimented on the bottom side that you would never see. So that's almost ready to go. And then that goes like that. There's a problem. Yeah, that's hitting coil there. So yeah, I'll have to figure that out. I may have to, let's see, if I put that vertical like this. Yeah, that'll fit. So yeah, I just answered that question. That's going to mount vertical like that. and that'll work. The next board I will build will be that capacitor bank. And again, there's 8 of those big capacitors. When you're buying stuff like this, this is the one that Eastern recommended. Now they sell them on their website for $10 each. I found them under the websites for about $12 each. I see them on eBay anywhere from 9 or 10 all the way up to $20 each. I managed to find one seller on eBay that was selling them in lots of 3 for $6 each. So I only needed 8, but I had to buy 9. But I got them for $6 each instead of like $10 each. So make sure you take your time and shop around, get the better deal. But that'll be in the next video, is making the capacitor board there. And that'll probably be a much shorter video because I don't have to explain the whole operation here. So I guess the point of this video was just to kind of show the basic operation, show the first board that I've got, and just let you know that it is in progress. I know the last video I put out was a long time ago, and any of you that saw that may be wondering what the heck happened. Well, it is happening. It's just I'm waiting for parts. Anyways, like I said, I'm going to end it here because I'm rambling. It's going on way too long. Next video, hopefully 3 or 4 weeks maybe. I don't know. I got other projects I'm trying to put out. And as always, until next time, thanks for watching.